Thank you. I'm really excited to be here today and to be part of this Insights series. VideoRay has played a really big role in my organization over the last 12 years now, and I'm excited to share how that's happened and give you a taste of some of the other projects that we've been working on. So we'll get right to it. Rosalia Project, our organization, is a nonprofit based in Vermont. We're up here in the mountains, the rivers and lakes. Of course, everything's connected. And our mission is to clean and protect the ocean, conserve a healthy, thriving marine ecosystem. And we've been primarily working on the problem of marine debris. And we use 4 strategies to do our work. And they are to do data cleanups, always collecting data. And then everything else is very solutions and prevention oriented. So prevention through education, embracing innovation and technology. And like I said, a lot of that technology has been ocean engineering and ocean technology, not just like the VideoRay, but the VideoRay, and to do solutions-based research. We address the whole water column from the surface to the seafloor. So obviously the shoreline. We operate from a research vessel, which I'll get to. So we address the surface, and of course the seafloor. Thanks to Hector the Collector, we did name our VideoRay. This is a Pro 4. We have a deliberate, from the start, focus on our urban, inland, and coastal waters, the land-sea interface, where the majority of marine debris comes from. And we have spectacular partnerships. In addition to companies like VideoRay, we've worked with TriTech, Blueview, and KCF. We have partnerships with universities like MIT's Environmental Solutions Initiative, the Forensics Department at Staffordshire University, national organizations, funders, and local, regional, and even global partners. We are optimistic. In the face of an overwhelming problem, we're optimistic because we recognize the collective we made this problem, and we believe the collective we can fix it. Here is our spectacular research vessel. I'm one of her captains, and this is a spectacular boat. I could talk about this a lot, but it's a short presentation, so I will just say that one of the things of which I'm most proud is that we have solar, wind, and hydropower on the boat. And we haven't plugged into shore power or used our generator to specifically generate house bank power in 8 years, thanks to this combo. In terms of the marine debris problem, we address derelict fishing gear, consumer debris, and microplastics. The way we look at it is the whole thing is about getting to solutions. And we have this kind of working flow chart that gets us from what we think is the beginning, which is understanding a problem, to solutions. Our area of expertise is primarily in the field science part of understanding the problem initially, and in education, awareness, and innovation as far as solutions go. And I'm going to share a little bit about that. But first, I want to talk about what we've done and are doing with our VideoRay. This piece of technology has been a central part of our work since the very, very beginning. And we've used it really in 3 different ways. Some of it is to understand the ocean and our lakes and rivers more, and some has been to connect, the majority, to connect people to those places. So in terms of our projects, one of the biggest projects that we used the ROV for wasn't actually specifically about marine debris. It was to show that marine protected areas work. And we were doing that in the Stellwagen Bank area and other parts of the Gulf of Maine. And we wanted to produce a visual campaign to say, this is what it looks like where areas are protected. And in a similar place, this is what it looks like when they're open to trawling. And they're pretty powerful images. I know the next speakers are going to talk a little bit more about this, so I'm going to move on to our more marine debris related efforts with the ROV. So here's our setup on American Promise. This is how it looks when we're just doing work like that on the marine protected areas, or I'll get to in a bit, doing derelict fishing gear surveys. It's pretty comfortable. But this is what it really looks like when we start using this equipment to both do the science and research, but also, so importantly, connect people to the underwater world right at their feet. Whatever's down there, whether that's lobsters and crabs, which we see a lot of, and it's not really or usually, it's and piles of mostly consumer debris or leftover derelict fishing gear. What I love about these pictures is that they span generations, and in nearly every instance, except that one guy in the back, everyone is engaged. I'll go back. Every single kid here is engaged. Everyone but that one guy is fully engaged in what we're doing here. And same with this. We've operated on remote islands. That was the one before. This is at a yacht club. And what we're doing is we are combining the underwater technology with this problem of marine debris and the connection of the underwater world right under people's feet. One thing I think is really interesting is how there's people who cannot tear themselves away from the screen. And there are people who will just watch the sub, and they will watch just the tether. That's it. In anticipation of what the sub will bring up in its grippers. It's pretty fascinating. There seems to be sort of two camps there. That would be a fun social science experiment. But whatever happens, we have found this tool to be extremely powerful and accessible. And we've been certainly grateful for the partnership and opportunity to get to use it. So here's this is something that we play a game, and you guys can give it a go too. So some of these are obvious, but if you want it in the chat, throw down, do you see a creature in the top left? What is the creature that you see? And the next one, I'll tell you the answers in a sec. On the bottom row, the one on the left, circular thing. See what you think that is. And then the one smack in the middle. That's also pretty challenging. Now, the fact that I can't quite see your chat, so I'll be able to see this after. If you see a crab right in the top middle of the top left, you were right. That's a crab among lots of beverage containers. This is a plastic, like champagne glass of sorts. There's a pair of jeans in the New England Aquarium, just off the New England Aquarium. So this round thing, middle left, that's a roll of duct tape in Annapolis. This middle, that's a drill charger. So if you drill battery. So looks like a toy tugboat to me. Anyway, next we have kind of so frequently found water bottle. We do not frequently find traffic cones. And then a can, probably a beer can, and then a ubiquitous Solo cup. So that's something that's fun. We find that this connection, it's really eye-opening to people, and finding everyday items that everyone uses is particularly inspiring for the topic that we're covering, to just understand that a lot of this stuff escapes our waste stream. If you're wondering what this is a linified image. So the middle is using the linifier, which is good because this is in the Charles River. This is a target-rich environment with very little visibility. And incredibly, this is a ship's bell that we picked up, and it sits at Community Boating in Boston right now. We've used partner or adjacent technology to do our work, and with the ROV to help with ground truthing. So one of our big projects that is derelict fishing gear related is to do derelict fishing gear surveys with partners along the Gulf of Maine. We are actually hopefully embarking on another one of these soon, but we found some interesting things here. This is with the Tritech Toad sonar. And you can see a shipwreck, and then here's these three are a working trap line of 3 traps. And these rectangles are just probably single traps. Maybe these are 2 together. This one might be derelict. And with the blue view, with the multi-beam sonar, we've been able to really get incredible detail of both traps, and so there's a trap, and then even those strong returns, those are cans. So we were able to actually fly the ROV in to pick up individual beer cans this was also in Boston. So here's a particularly noteworthy occurrence for us. This was one of the most highest concentration area of marine debris that we've encountered. Interestingly, it's in Newport, Rhode Island, and it's not in a lot of water, but it's just in a place where we think both the current and the prevailing breezes and the proximity to shoreside dining establishments really put a lot of stuff in the water and then accumulated it all right here. After this discovery, we had the good fortune to have Andy Goldstein bring his sub as well. And the two of us and my team spent a while picking this up. And then eventually we brought some divers in to clean it up. And it was pretty fascinating. For those of you that follow the marine debris problem, there's an interesting mass balance issue between the amount of marine debris that's calculated is flowing into our world's oceans and the amount that's sort of been officially counted or found. Obviously, those are extrapolations. And this mosaic has actually played a role in being shared in not just my own presentations, but those of other people who are working on this problem to understand just how much of it is coming off the surface, is not turning into microplastic and then floating around, but is sinking. And what's really interesting here is a lot of this stuff that's on the bottom technically should be floating. So its specific gravity is buoyant in salt water. And so there's issues such as colonization by sea creatures and algae and things like that is changing our ability to just make assumptions, and being able to see it's making a big difference. Other types of underwater technology that we're using isn't necessarily underwater. So we are using drones as well. That helps us make similar mosaics, but in other places. This was looking at a reaccumulation after we'd cleaned a place. And we even sometimes travel with 3D printers as part of a solutions workshop where we do a data cleanup and then we consider the problem just right there locally. We talk about how that fits in regionally and in a bigger picture, and then work on solutions. And we encourage people to consider solutions in their area of expertise. And that's not always on a super technical side. Sometimes that's messaging. So that was Dwayne, the sustainability turtle that the guy in blue there designed. He's explaining it to his friends there. Sometimes the design projects that people take on are very, very clever. This is Tiger, and he designed, and we 3D printed for him a little cover for the scuppers of fishing boats that you could flip up and down, still lets water flow, but has opening size that is smaller than one of the most frequently lost items, which are the rubber bands, and the next size up would be little Red Bull bottles. So that keeps them available before they can wash out. Okay, so to kind of bring things on the other side of our latest projects, do you know what we're looking at? If you're thinking to yourself that you are looking at microfiber pollution before it actually flows away from your house in the drain water, you'd be right. What's happening is that our clothes are breaking up, and they're doing it while we're wearing them, while we're washing them, and while we're drying. But when this first news broke, it was really all about washing. And so that's where we started our focus. This was quite a while ago. And so we wanted to look at the problem of microfiber pollution. We started with washing machines, and this is filtered from a load of kind of everyday clothes. It's filtered, dried, and magnified. Now, what's interesting about the microfiber pollution problem is that it really isn't willful disobedience. People aren't running around dumping microfiber or just kind of being careless and losing it. What's actually happening is that our clothes are kind of vulnerable. So I don't have a lot of sort of editorial to say that our clothes are terrible so much, but what these magnified images show is that there are types of textiles that are particularly vulnerable to breaking and having these little pieces of whatever it is our clothes are made of. The majority of global clothing is synthetic. though our non-synthetic but man-made, or call it anthropogenic, textiles still have the ability to cause some harm. Real quick, from top left, we're looking at acrylic. Then we have two different polyesters. So not only is the material important, but how it's made. So a kind of tight weave and an open weave, like a fleece, the third one from the left. And top right is a cotton poly blend. So that's like t-shirts. The bottom left, I think, is particularly beautiful. It's of a black wetsuit. So what we're looking at there is the nylon skin of a neoprene wetsuit. Then we have nylon spandex. So those are your yoga pants. And then linen, rayon, and then cotton. So these are natural, but often covered in chemicals that we don't necessarily want in our public waterways. So very vulnerable. Our clothes are potentially vulnerable. And these little bits of fiber that break off of our clothes are very small. This is a piece of spaghetti, a piece of pasta magnified with just one little tangle of fiber that we got from the effluent water of a washing machine. So when we heard about this problem, it was a problem that just screamed at us. And we set about trying to do three things as it relates to microfiber pollution. We wanted to learn more about the problem and contribute scientific knowledge. We wanted to see if we could come up with a solution, and we wanted to spread the word and raise awareness so that people in other industries could work on the problem as well. And so on the side of understanding the problem better, we set out on an expedition to see what microfiber looks like in the wild. And we sampled the Hudson River in New York State from Lake Terror of the Clouds in the Adirondack Mountains all the way to Ambrose Light, where the Hudson meets the Atlantic. We took surface samples every 3 miles. It involved hiking and whitewater rafting and American Promise and only a little bit of trespassing and apologizing later and that kind of thing. But what we got was really interesting. We set about thinking that this would be all about wastewater treatment plants. And in fact, one of our hotspots, our biggest one, was the one that was closest to a wastewater treatment plant effluent or outflow. But what also happened is that the area north of, higher up current of the first wastewater treatment plant had multiple hotspots. And not only that, but statistically speaking, across the whole river, we did not see statistically significant difference in concentration. And that, of course, indicated additional sources to this microfiber problem. To me, that meant some kind of atmospheric deposition, whether that was from runoff or dryers or recreation. And so, as often happens with science, it asked more questions. And with National Geographic Society's support, we went back, and this time on the Hudson River, same locations, we sampled the air in 2 heights, up the mast and at my inhalation height, the soil, the surface, mid-water column, just above the river bottom. And then we partnered with a company who uses some cool spectrometry to look at nanoplastics. In addition, we supported some science-enabling innovation for microplastic work, and I'd love to talk about this for those of you that are interested specifically on this trip. And right now, we are writing up those results. I'm going to share a little bit. So this is a sort of overview, and I'm happy to talk more specifically with anyone who's interested about any of this. I'll have my contact information at the end. But as part of this Hudson River trip, we also did a specific wastewater treatment plant study to look at the effect that the effluent or the outflow of wastewater treatment plant might have on the overall microparticles in the river. So we took 27 samples. So this is very high resolution. The 0 is at the location of the effluent, the outflow, and then half mile on either side up until 2 miles. And I'll just share, this isn't ready, please don't tweet this, but this isn't ready for sharing. We're working on it now, but this is some of the kinds of information that we're looking at that's interesting. This is, we have the Hudson, which is a very rural wastewater treatment plant, Yonkers, which is suburban, and a location in the East River, right between Brooklyn and Manhattan, which is extremely urban. You can see along the top are some material types, and there's something going on with blue polypropylene that was also had a lot of colonization on it. So we're working on that. Stay tuned. We also did some work on drying. So that was about washing, related to washing machines. We've also kind of investigated this problem as far as dryers go. And this is published and available in open access on PLOS ONE. We use snow as an enabler to look at what happens when the electric clothes dryer emits things straight out into the environment, which is what all of our electric clothes dryers pretty much do. And we found that fibers from our drying event, we used a pink fleece blanket, went as far as we're in every single one of the plots we had, which were up to 30 feet away. And this was the total amount of fibers that were escaping the dryer in the first place. Happy to talk more about that. And then we've also done a contamination study. This was another pilot study that was on the Hudson River, but this was about specifically contamination. In the end, what we learned was about what happens when we wear our clothes. So we washing, drying, and this is about wearing. This was just published a few months ago in Marine Pollution Bulletin. I'm happy to share this. But what this is we wanted to know what our microplastic and microparticle samples had in them as far as fibers that we were responsible for. So we had samples of all the clothing that we wore, and we had air blanks, and we scraped little scrapings from sail bags and ropes and everything. And we found that when we didn't use protocols, which was like washing and everything, when we did use all the protocols in the red, we still had 33% contamination, which is a lot. But then we realized if we didn't use any of the protocols to keep out contamination, nearly just over 70% in the field or the on deck part, and just under 70% in the processing part of the system was contamination. Now, what this all means is that we are all pig pen. We are basically walking around, and instead of a cloud of dirt puffing off of us, I think it's a cloud of microfiber. And so that brings us to the very end, and that is right now our working solution to microfiber pollution. This is the Cor Ball. This is what it looks like. It is made of recycled and recyclable material, and it helps collect fibers before they could wash out the drain. It also collects hair if you have a lot of it like me, that's handy. And what we're looking at here is a fuzz ball that we pulled off the Cor Ball, and that's it. So there is some hair in there, the big brown thing, but there's also an incredible amount of fiber that you really can't see with your naked eye. And there it is, Stumpy Pencil going to show you that little clump. The Cor Ball is not the solution, but it is certainly a solution to help reduce the amount of fibers that are escaping our washing machines. But we're also excited to say that it also helps protect your clothes by reducing shedding in the first place. So to wrap things up with our recommendations, we get a lot of questions. So this is to preempt questions on what you can do about microfiber pollution specifically. There's a fair number of things that you can do before even spending any money. So cold water makes a really big difference in protecting your clothes, only washing them when they need it, that kind of thing. Obviously, a Cor Ball helps. Aftermarket filters are excellent, and that's the way we need to go, I think. And then air dry when possible. We still have a lot to learn for drying. But I'd love to just spend one more minute before taking questions on what you as VideoRay owners can do in the big picture of ocean protection. And these are my top 4. So what I mean by make yourself and your gear available is kind of throw it out there, or when scientists or educators call, you could offer to do a program on a dock and just to see what's down there in real time. You got to be okay with people kind of crowding up to you. So maybe a little bit past you can have big screens. I was going to say past the pandemic, but it's spectacularly satisfying for everyone. And we haven't found an age group that isn't interested in seeing what is under the water, in real time. Be a science teller. So I'm lucky enough to be a National Geographic explorer, and part of that is learning to get better and better at explaining technical efforts, science, technology, what you see, what you do, the equipment that you're using. think about ways to share your work and your equipment and explain it to people, because it's fascinating. And the VideoRays are accessible in a way that very few other pieces of that level of technology are. Reach out with observations. So what I mean by this is, if you see something interesting, what if you found a huge area of trash or a particular accumulation of homogeneous trash or something, find me. If you see fish that you've never seen before, find your local fish person. But if you, even if you're working on something else, so you're observing something else, when you make observations in another field, please reach out with those. It'll make a difference. And then my last is to be a ship or an ROV of opportunity. And what that means is to make yourself available to bring researchers with you. Not necessarily just your own work, but to sort of let people like me do mine with you on your boat, wherever you are. And to make that even, I'll invite all of you to come on our boat where we are. Here's my contact information. We have opportunities for people of all academic, professional, geographic expertise and locations to join us. We operate in the Gulf of Maine primarily, but please take my information down, and I think there's room for 1 or 2 questions.
Thanks so much, Rachel. That was a really fantastic presentation.
Thanks.
I have a question. Now, what are some other innovative solutions to marine debris, things that are similar to the Cor Ball?
There are some really cool innovations. I'll give you some big scale one. It's actually not far from you. I don't know if you've all seen the Professor or Mr. Trash Wheel. That is a big scale, run by the power of the water trash, or passive trash collector. Another one's very cool, by a group in Amsterdam called the Great Bubble Barrier. And they realized that when ships or fish or whomever needs to access the canals that are also full of trash, they can't just put a barrier over an entire canal like the trash wheel would. So they realized that a bubble net will do the same job. If you're a piece of trash and you can't swim, bubbles will divert you to a collection zone, but the fish or an ROV or a boat can swim through. So those are 2 of my favorite.
Great, thank you. So we have a couple questions here from participants. Vino asks, can the system identify invasive species other than garbage?
Oh, that is great. My guess is perhaps my subsequent presenters might talk about that. I don't see why not. I'm going to leave that to the next people. I think there's tremendous opportunity for machine learning and AI here. And so my guess is yes, but I'll leave that to people who do a little bit more work with creatures. Or actually, creatures and plants.
Great, thank you. Andrew asks, what kind of clothing fabric can be used to decrease microfiber pollution?
Great question. So as far as benign, as chemically benign, the best you can do is organic down to the dyes. But what's interesting about that is we think cotton sheds a lot more than other types. So you're looking for a kind of balance. What we look for is, I still believe that technical clothing must be worn. I am an outdoor sports person, and clearly I spend a lot of time on boats and things. And so I do believe that we still need synthetic technical clothing, and the lower shed it is, the better. So since doing this, I do try to keep my fleece from being the outside most thing. And try to keep the tightest weave options as outerwear. We're still learning this, though, and it's something that I and my group is pushing for, is more work on first understanding what's the most resilient clothing and then making more of it. Appreciate that question.
Great. We're going to ask one more question. Do you use CTD sensors and fluorescent to mature kelp growth?
Yeah. So
Measure
yeah, yeah,
kelp growth.
yeah, I see that one. I would. If we were doing more work in that kind of in that world, we certainly would. I am not familiar back when we were doing this like our protected area work. I didn't know if there was a CTD that fit on the ROV that was accessible to us. But certainly subsequent work, the more data that is collectible, the better, as far as I'm concerned, especially going back and trying to understand problems after we've done these huge expeditions. So I definitely am a fan of piling on as many sensors as is reasonable, because you just don't know where the connections might be.
Great. Thank you again, Rachel. For the sake of time and getting to our next presenter, we're going to wrap up this session. Thank you again, Rachel.
Thank you for having me. And for all the support all of these years. Really, the VideoRay Hector has been and is part of the Rosalia project team. And for that, we're really grateful.
Thank you, Rachel. Yeah, we really appreciate it.